Far above us, when the night sky turns quiet and the stars begin to shimmer, one question has echoed through it as a question older than science itself, whispered by ancient philosophers and chased by modern today. That question feels closer to an answer than ever before. This shift comes from a technological marvel orbiting far beyond Earth, the James Webb Space Telescope. Built to see what no telescope has ever seen, JWST gathers faint light that has traveled across space for hundreds of years. Within that ancient light are secrets of distant worlds, and among them is a planet that has stunned scientists. About 120 light-years away, in the constellation Leo, a small red dwarf star quietly burns. Circling it is a planet known as K2-18b, a world that, at first glance, seemed unremarkable. Just another dot in a growing list of exoplanets. But as JWST focused its powerful instruments on this system, K2-18b revealed itself as something entirely different. This planet belongs to a strange category called sub-Neptunes. These worlds are larger than Earth but smaller than Neptune, a type of planet that does not exist in our own solar system. They are neither rocky like Earth nor fully gaseous like Jupiter. Instead, they may host thick atmospheres, deep oceans, or exotic environments unlike anything we've ever encountered. K2-18b orbits extremely close to its star, much closer than Mercury is to the Sun. Under normal circumstances, that distance would mean scorching temperatures. But red dwarf stars are cooler and dimmer, allowing K2-18b to sit within what scientists call the habitable zone, where conditions might allow liquid water to exist. And that possibility became far more real when JWST detected water vapor in the planet's atmosphere. It was a breathtaking discovery. Water alone does not confirm life, but it is the foundation upon which life as we know it is built. Scientists then searched for additional clues. Using transit spectroscopy, a method that studies how starlight changes as it passes through a planet's atmosphere, researchers identified methane and carbon dioxide. These gases can form naturally, but together they suggest complex chemical activity. Then came the most surprising signal of all. Early observations hinted at the presence of dimethyl sulfide, or DMS. On Earth, this molecule is produced almost exclusively by living organisms, particularly microscopic life in oceans. If confirmed, it would represent one of the strongest potential signs of life ever detected beyond our planet. Researchers remain cautious. Data must be verified, alternative explanations tested, and natural chemical processes ruled out. But even the possibility has transformed how scientists think about life in the universe. K2-18b may not resemble Earth. It may not have continents, forests, or familiar skies. Instead, it could host life in vast, deep oceans beneath a thick hydrogen-rich atmosphere, a concept once thought impossible. This idea connects to a revolutionary class of worlds known as Hycean planets. These are theorized to be ocean-covered planets wrapped in hydrogen atmospheres, capable of maintaining liquid water even in extreme conditions. The hydrogen acts as insulation, trapping heat and stabilizing temperatures. In some cases, these planets could be dominated by water, forming global oceans thousands of kilometers deep. K2-18b fits this model almost perfectly. Its size allows it to hold a thick atmosphere. Its orbit places it in a stable temperature range. Its atmospheric chemistry hints at water, carbon compounds, and possibly biological activity. For astronomers, it is one of the most promising candidates ever discovered. What makes this discovery even more remarkable is how little data was required to raise such profound questions. Just a few hours of JWST observations were enough to reveal a complex and dynamic atmosphere. With more observations planned, each new data point will sharpen our understanding of this distant world. Is the DMS signal real? Could unknown chemical reactions mimic life? Or are we witnessing the first true biosignature beyond Earth? These questions now drive the next phase of exploration. Future missions are already being designed to follow up on discoveries like this. New telescopes will study hundreds of exoplanet atmospheres, searching for patterns, chemistry, and signs of habitability. Some concepts even aim to directly image distant worlds, revealing oceans, clouds, and perhaps unmistakable markers of life. But even now, something fundamental has changed. For decades, scientists searched for another Earth, a familiar twin with blue oceans and green land under a sun like ours. K2-18b challenges that idea completely. It tells us that life may thrive in environments nothing like Earth. Beneath hydrogen skies. In global oceans. In chemical systems we are only beginning to understand. The universe is not limited by our expectations. It experiments. It innovates. It creates worlds more diverse than imagination alone could invent. If planets like K2-18b are common, and evidence suggests they may be, then the universe could be filled with potential habitats for life. Not just a few, but billions. Each one a silent laboratory where chemistry may have crossed the threshold into biology. The search for life was never about finding a mirror of ourselves. It was about understanding what life can be, anywhere. And now, with each new discovery, we are redefining the boundaries of possibility.